Good afternoon. Welcome to Think Purple Math. Today's topic, or the topic of this video lesson, is solving absolute value equations. These equations can be more complex than what you're going to see on this particular video, and they will be presented down the line, more complex versions. But as I always typically will probably do, I'll probably put a few little hints, teaching points, reminders, processes that we might want to consider before we begin solving absolute value equations. If I'm looking here at my little tablet here, I see that the first thing we want to do is we want to isolate the absolute value equation, or the part of the absolute value equation. The second thing we're going to do is we're going to take the absolute value equation and we're going to rewrite it into two equations, because from our definitions on absolute value, you need the positive side as well as the negative side. The third thing we're going to do is to solve each side of each equation, or solve each equation independently, and then we're going to go ahead and present the answer after we conclude the solving. So we're going to have 6 little absolute value equations that we're going to look at, and then we'll go from there. Okay, so this is the topic of this unit, of this lesson, as solving absolute value equations. All right, we'll go ahead and look at our first one. I have the question 1Q, and 1A is the answer, will be on the next page. Absolute value of 3x is equal to 9. The first thing that I notice is that the absolute value symbol is isolated already, and it's on its own. It's on the left-hand side of the equation. So we're going to go to the next step. And the next step is to separate this equation into two versions. The first equation is, and I tell my students, simply write the equation as you see it, just as it is. That's only after you have separated and isolated the absolute value. So 3x is equal to 9. But 3x would also equal negative 9. So that would be the, and I ask my students, I'll say, you need to be able to recognize the split, and you need to be able to determine how you're going to split this equation into two. And after a little while, they get the hang of it. Not everybody, but it takes practice. So here we are. We have the two equations that we need, so we're going to simplify each one independently, order by inverse operations. So x is equal to 3 is one answer. Divide by 3 on this side, and x is equal to negative 3 on this answer. When working absolute value equations, you're going to have one of 3 scenarios. One, you're going to have 2 answers. The second possibility is you're going to only have 1 answer. And there's a few cases that are very rare, but they do exist, where there's going to be no solution. No answer will actually work to get you the absolute value solution. So we're looking for a 3 and a negative 3, and we'll go ahead and flip it, and there you are. We'll go ahead and look at another one. Now we have one that has a fraction. The same process remains, so we have the absolute value of n divided by 3 is equal to 2. The absolute value symbol is isolated, therefore we don't have to do any more. We don't have to rearrange the equation and get the absolute value, so we're good there. So we're going to go ahead and work below the waterline, and we're going to recognize the split. N divided by 3 is equal to 2. And we'll separate that. And we have n divided by 3 is also equal to negative 2. So that's where we stand, and that's where we go from there. Now we'll simply do inverse operations. The variable is n being divided by 3. So the opposite is multiplied by 3 on each side. Any number times its reciprocal is 1. So n would equal positive 6 as one of your answers. Go here to the right hand side, multiplied by 3, and n is equal to negative 6. So if we wanted to check this, we could check it. If we put in negative 6 in the equation, we would have negative 6 divided by 3 in the absolute value, and that would be the absolute value of negative 2. And absolute value is the distance that number is away from 0 on the number line. That's why it always is you cannot have negative distance. So the answer would be 2. If we change this number to positive 6, then we get a positive 2. You're still going to get a 2. So this in fact does check out. We have a 6 and a negative 6 as our final answer. Alright, we're going to go ahead and go up a little bit in terms of difficulty. Hopefully we can, now we got a little more complex version of that process. Now notice in the right hand corner at the top you see the initials in pink, IF. What I do with that is sometimes I let my students kind of have an idea, some foresight about what the answer might look like. I stands for integer. An integer can be a whole number or a negative whole number or even 0. And F stands for fraction. So that's a little heads up that I use to let students know, not always, but sometimes, let students know, look, we're going to have one integer answer and there is going to be a fraction answer here, so don't get alarmed when it happens. So we'll go ahead and solve this. We notice that the absolute value has been isolated. It's on the left, so we're good. We're going to recognize the split this into 2. The first equation is going to be exactly as it sits without the absolute value. Negative 4 plus 5x equals 16. And I'm going to separate it with a little line. And we're going to have negative 4 plus 5x is equal to negative 16. Once you recognize the split and split the two equations, then it's using your inverse operations and traditional algebra solving equation rule. So we'll go ahead and go from left to right. We're going to add 4 here and add 4 there. We have a 5x is equal to a 20. So far so good, no problem. Divide by 5 on each side. We have an x is equal to a positive 4. Well, since there's an integer fraction, the next answer looks like it's going to be a fraction. And let's take a look and see what we come up with. Add 4 and add 4. The 4's will cancel. We come down, we have a 5x is equal to a negative 12. And 5 doesn't fit into negative 12, but we're going to simulate, or we're going to go ahead and show the division process. So it's negative 12 fifths. So x is also equal to negative 12 fifths as your secondary answer, your second answer. 4 and negative 12 fifths. The process really remains the same regardless of the complexity of the absolute value equation. 4 and negative 12 fifths. And we're about halfway through. Here we go. We have II stands for integer. So we'll go ahead and work below the water line. Negative 2a minus 1 is equal to 11. All I'm doing is writing the first equation exactly as it's presented. And negative 2a minus 1 is equal to a negative 11. So we have the positive and negative version. Now we just simplify each side. We add 1 to that side and add 1 to that side. We have a negative 2a is equal to a positive 12. Then we divide both sides by negative 2. So a is equal to negative 6. That is one of our answers. Do the steps on this side. Add 1 and add 1 here. That cancels out. Negative 2a is equal to, now this is not going to be 12. It's going to be a negative 10. Divide by negative 2. And a is equal to positive 5. So we should have a negative 6 and a positive 5. You can always pause the video, replay it, what have you. Whatever you need to do. There's our negative 6 and positive 5. Okay. Here's another type of problem. Now we actually have to isolate the square root. I mean the absolute value symbol. Excuse me for that. Notice that we have the absolute value of 5x plus 5 is equal to 45. So what we're going to do here is we got to get the absolute value isolated either on the left or the right. My preference is to put it on the left, but it doesn't always work out that way. In this case it will. I'm going to subtract 5 on both sides. Now what I warn students is don't do this. Notice how I just put down 5x here, but the 5x is actually still inside the absolute value symbol. And that's a mistake that is often made, and hopefully we can avoid that. Now we have the absolute value on its left-hand side by itself, and we'll go below the water line. 5x is equal to 40, just like it sits, and 5x is equal to negative 40, the negative version. Had this answer on the that I'm pointing to had been negative, this answer on the right with the 2 arrows would be positive. So you always do the opposite of what the left hand side is one way and the right hand side will be the other way, or the opposite term, opposite sign. Alright, so both of these we're going to divide by 5. This is a simple one now. X equals positive 8, one answer, and x equals negative 8, which is your second answer. So 8, negative 8, final answer. There we are. Rock and roll. All right, one more for the road. This one is an integer fraction answer, and this might be the most complex one. If you can get to this level, that should be fair for now. You know, you should be okay. Learn how to do these. We got a couple things here. We have a 6 being multiplied out front, and we also have a negative 9 being attached. So we're going to treat the absolute value symbol right now as like a little variable on its own. So we want to get that variable by itself. We're solving for that. So here's how we're going to do that. It's going to take an extra step or two to get it done, but we're going to be all right. So first thing we're going to do is we're going to add 9 and add 9. Those 9s cross. 6, absolute value of 1 minus 5x is equal to 66. And as I mentioned previously or in other videos, once you make your first step, the other steps will probably present themselves, make themselves apparent, which will happen here. We have a 6 being multiplied here, so we're going to divide this side by 6. It's technically all the way across, and we're going to divide the right hand side by 6. This crosses out. We have an absolute value of 1 minus 5x is equal to 11 now. Okay, we've isolated the absolute value. We're going to do the rest of the work below the water line. 1 minus 5x is equal to positive 11. And 1 minus 5x is equal to negative 11. And notice, remember at the top it said integer fraction. One of them is going to come up evenly, either positive or negative whole number, but the other answer is a fraction. Let's take a look. Subtract 1 on both sides. This crosses out. This negative stays with the 5x, so it's negative 5x is equal to positive 10. Divide by negative 5. X is equal to negative 2. And we'll make a little answer box right here. X is equal to negative 2, and x is equal to some other style or some other answer here. So let's go ahead and subtract 1 there and there. We get negative 5x. You need to extend this line to separate, that's fine. I got negative 12. Divide both sides by negative 5. We have an x. A negative over a negative divided by makes it positive, and it's 12 over 5. So our second answer is 12/5. Our first answer is negative 2, and that is your final answer. So let's take a look, and there we have negative 2 and 12/5. Well, that's it for this lesson. I hope you understand that. I hope it helped you learn this concept. Feel free to, if you know me personally, talk to me and ask me for guidance. You want me to make a specific video on something, I'll be glad to do it. And always remember, you can always visit Think Purple Math and YouTube. And remember, always think purple. Have a nice day.